Hi, Doctor. We are from Group 15 and would like to present our CPC 45272. This assignment is designed to provide an interactive scaffold assembly experience using Pico for VR headset. Let me introduce my team member. There are 5 members in our team, which are Muhammad Abdullah Sahib, Chan Yiswan, Chen Zerun, me, Wong Wenyi, and Zhao Ran. Now, I will give the introduction of concept, target audience, and platform. Our assignment is titled Scaffold VR, and the core concept is to provide users with an immersive scaffold assembly experience using virtual reality. The purpose of this assignment is to create a VR training simulation that focuses on scaffold assembly procedures and the development of spatial design skills. Unlike other VR safety systems, this assignment does not emphasize safety protocol or hazard prevention. Instead, our system is purely focused on teaching users how to recognize scaffold components and assemble them correctly in a virtual 3D environment. This VR assignment helps users visualize the structure of scaffold and practice the step-by-step process of scaffold building in an interactive way. It allows users to understand how each part fits together to form a complete scaffold frame. The key learning goals of this assignment are to help users correctly identify scaffold parts such as budget, legend, standards, and bracing. Second goal is to allow users to practice scaffold assembly procedures repeatedly until they are familiar with the sequence and part placement. The last goal is to improve the user's spatial awareness, which is essential in real construction work as scaffold assembly requires understanding of distance, angle, and part alignment. Our target audience for this VR assignment include two main groups. The first group is high school students, especially those who are in technical and vocational education program. These students may not have regular access to real scaffold materials or live construction environments. Our VR system gives them a chance to explore scaffold paths and practice assembly in a virtual space, which make learning more accessible and interactive. The second group is vocational trainees and construction beginners who need to practice scaffold assembly multiple times. These users often need a lot of hands-on repetition to build their confidence and skill. Our VR assignment allows them to perform this practice in a virtual environment that is flexible, efficient, and free of real-world risks. With the use of VR, training is more engaging for both groups because they can move, grab, and assemble scaffold parts in an intuitive way. It also helps them to prepare for real-world scaffold assembly by improving their understanding of how scaffold parts fit together. We developed our VR assignment using Unity 3D, which is a powerful and popular game engine widely used in the VR industry. Unity provides the tool to create complex 3D environments and realistic physics, which are important for scaffold assembly tasks. The physics engines help us simulate grabbing, moving, and placing scaffold parts in a natural way. Unity also supports a large community, meaning we could find tutorials, guide, and additional tools when we need help. It's a very suitable for VR development because it works well with different VR SDK, including the one we use. For this assignment, we integrated the Pico Unity Integration SDK, which is basically designed for the Pico 4 VR headset. This SDK is important because it enables accurate heat tracking, which allows users to look around freely in the VR environment. Second, joystick-based navigation using a Pico controller, so user can move smoothly and comfortably around the scaffold assembly area. Next, controller input support, which is essential for scraping scaffold part and selecting material from the UI panel. The Pico SDK ensures that the system is optimized to run smoothly on the Pico 4 headset, which is our target hardware.
Hello, Doctor. I'm Jora. Let me introduce the detailed team structure. Our team structure was clear, divided to ensure efficiency. Each member was responsible for different aspects, such as environment modeling, overall vision, gameplay scripting, interactive logic, UI design, feedback system. All this clear division allowed us to compare our project effectively as a team.
So basically, in the next slide, we're gonna go through the whole VR system concept and the whole flow of the concept as well, how the whole thing flows down, right? So let's talk about the concept breakdown here, right? So let's start with the environment here. First, we actually choose an open daylight yard, and that's bounded by skyboxes and concrete walls, right? So there's no flashing billboards, no wandering NPCs, and just enough scenery to feel like a site, but clean enough to keep frame rates high, and wide floor space lets the joystick motion feel natural. And then at the two, we have gameplay, right? In the gameplay, we have basically a feedback system, virtual bass jack, and a walk or strafe right on the ghosted socket. In the three, we have feedback system, which we have three layer cues, so every learner type catches at least one. There's a visual, audio, and haptic. And at the four, we have a timer. The moment the trading lifts the first part, the stopwatch appears in the top right corner. Each error adds a 5 second penalty. Completing under 2 minutes with fewer than strikes earns a virtual competent stamp, and that's how together these four mechanisms turn a flat safety lecture into an embodied drill, right?
Good day, doctor. My name is Yixuan with metric number 159377, and now I am going to explain the storyboard for this VR system. So first, we have a welcoming interface where users are greeted with a clear introduction to the VR system. The screen contains three LAN buttons: the Start Experience button for immediate entry into the simulation, the Log button, and the Tutorial button for first-time users who need guidance. Following, we have the tutorial UI, which provides the step-by-step instructions on how to interact with the VR environment. It explains the function of each control button and stated how scaffold components should be assembled. So once ready, user will proceed to the component selection screen. Here they can choose from four essential scaffold parts, including the base jacks for stability, ledges for horizontal support, standards for vertical framing, and braces for reinforcement. This interface mimics the real-world scaffold inventory, which help the trainee recognize the parts efficiently. So during assembly, users grab and position the components using VR controllers. The system assists with real-time feedback, which valid placement will display in green color, and this helps in spatial reasoning and reduces errors to ensure the professional scaffold safety. So after assembling the scaffold, users will see a summary screen displaying their total assembly time. So these metrics encourage the user self-assessment and iterative improvement.
Now we will move on to the live demonstrations using Pico VR headset.
Hi, doctor. So my name is Wong Wenyi, and today I would like to present our VR application. So this is a welcome screen of our application, and there's three buttons. So start experience, load, and tutorial. So if the user is first time user and don't know how to play our game, and they can just click this button, okay, and this guideline will show here. So this guideline will teach the user what button has provide which function and which component should connect to which component. Okay, so if they understand that, they can click the button understand. Okay, so if the user want to look back their progress, okay, they can click the look button. Okay, they can select the progress they want to pay. Okay, and now I will click exit first, and now I will create a new game by clicking this button. Okay, so you can see here there's a timer here. So the timer start to count the time when we start to get the component, SMB component. So now we get the first component first, get standard. Okay, so you can see here the green place means that we can put the SMB component there. Okay, so near the green place and put here. Okay, so when we put the SMB, the log UI will display. So this will decide we want to log this component or not. So if you choose log, so it means that this SMB component cannot be moved anymore. If we choose no, so we can remove the component. Okay, so now we select another component. So we put here. Okay, so we log again. Okay, so we have another button also. So for example, save button. Okay, if you want to save our game, we can save here. So save. So now our game is saved. And now this show a list of components. So it means that how many components we have pressed, we have put. Okay, and you can see that standard 1, basic 1, and total is 2. So this is correct. Okay, and now this is same again. So this is our SMB. So there's 4 type of components. Okay, and these 4 components will help us to complete all the scaffolding. Okay, and because of the complete scaffolding is too big, okay, and it's not suitable for me to complete all the material and show the final screen, so we will just use the simplified version of the application and demonstrate the final screen. And this I will pass to my teammate. Okay, so I think that's all from me. Okay, thank you, Doctor, for your attention.
Okay, thank you, Wang Wenyi, and I'm Chin Zelun, and now our talk will walk you through the ending logic of the game. So for demo purposes, we have set the game to end after placing 2 base jack. So now let us place the first. Yes, and the second base jack. So after both base jack are placed and the game ends, the timer stops and the end screen will appear showing congratulations, scaffold completed. That's it from us. Thank you so much. We are group 15 and that's it from us. Thank you.